Hey guys, Mr. T here. This is another video. This one is on the Hungarian algorithm, but for maximization this time. So, applied as stated previously, the Hungarian algorithm gives the optimal assignment for minimum results. So you're minimizing using the Hungarian algorithm straight up. To find the optimal assignment for the maximum result, you only need to perform one step before applying the Hungarian algorithm as normal. So to maximize, you just do one step in front of doing the Hungarian algorithm, and you maximize instead, which is the complete opposite of what you were doing before and in the previous video. So what is this step? I'm going to call it the maximization step, and it involves subtracting each number in the matrix from the maximum number in the matrix, and then you rewrite these results as a new starting matrix. So you look at the original matrix that you're trying to maximize, and instead you rewrite it after you've taken each number, each element in the matrix from the maximum number that was in that matrix, and then you run the Hungarian algorithm on that new one, on the new matrix that you've rewritten. So you apply the Hungarian algorithm, steps 1 to 5, to find the pattern of zeros, which will now result in a maximized optimal assignment in the original matrix after you've applied the maximization step. So, for example, Deb, Eve, and Fred have each requested a taxi. The taxi company has taxis A, B, and C available. The matrix below shows the time in minutes it would take each taxi to reach each customer. Find the optimal assignment of taxis to customers to maximize. So obviously, normally this question would be minimized because taxis would want to minimize the time they get to their customers. But I'm trying to pulling at straws here, trying to find you maximization questions. There's not many examples of those in other textbooks, and I don't want to use anything up that's already in your textbook, so I've just changed a minimization question to a maximization one. So we're going to assign the optimal taxis to maximize the customer's wait times Y, so that they decide Uber is a much better alternative. Okay, so my justification for that might be lame. I don't care. We're just looking for a way to maximize here as an example. So first step is the maximization step. Subtract each element from the largest element in the matrix, then rewrite. The largest element in the matrix is 10, so I'm going to rewrite this matrix with each element subtracted from the largest. So what are we doing? We're going 10 minus 5, 10 minus 4, 10 minus 7, 10 minus 8, 10 minus 6, etc. Okay? And 10 minus 10. So I'm rewriting this matrix, doing the maximization step. 10 minus 5 is 5, 10 minus 4 is 6, and etc. 10 minus 6, 4, 5, 4, 1, 0. Now we run Hungarian algorithm as normal. Now Hungarian algorithm as normal. Pattern of zeros in step 5 finds the optimal assignment to maximize instead. So step 1 is rows. What do we do with the rows? We subtract the smallest from each row. So 3 is the smallest, minus 3. 2 is the smallest, minus 2. 0 is the smallest, minus 0. So step 1 is going to come up with this result. 5 minus 3, 2. 6 minus 3, 3. 0, 0, 2, 3. 4, 1, 0. I've done the rows now. Columns, smallest result is 0, minus 0. Smallest result is 1, minus 1. Smallest result is 0, minus 0. The result matrix is therefore, I can write it smaller, 2, 0, 4. Minus 1 from all these, 2, 1, 0, 0, 3, 0. Step 3 draw lines through the zeros, and I've told you look for rows with multiple zeros first, columns with multiple zeros first, and then finish off. 3 lines were drawn, 3 rows in matrix. So we can skip to step 5. I'm just going to write here lines through zeros. We skip to step 5. There is no step 4 because we didn't have the issue where we've got less lines drawn than rows in the matrix. And skip straight over to step 5 and find a pattern of zeros. One in each column and row. So what selection can I do that's going to ensure only 1 0 in each column and row? This one is in its own row, so I can select that straight away. I could select either of these bottom 2, but thinking ahead, I can already see that if I was to select this one, I wouldn't be able to because there is one here by itself, and also I can already choose the top right one because it's in a row by itself, and that leaves me with this bottom middle one to select. So I've got my pattern of zeros, and this time because I did the maximization step, it's the maximize result. So in a different color, it'll be 8, 9, 7. Okay. Therefore, maximize weight times width B to Deb, 8 minutes. C to Eve, 9 minutes. A to Fred, 7 minutes. And you can total that up. 17, 24, 24. I believe that's 24. 17, 18, 19, 20, 20, 24 minutes total. Okay, so that is how you maximize. How? You just do this step before doing the Hungarian algorithm as normal. So hopefully that helps you out. Pretty simplistic, and I will see you in the next video.